Hello students, welcome back to your physics class. Now today we are going to begin with chapter number 5 and I hope you all must have completed your work up to chapter number 4. Now let us begin with this chapter. In this chapter we are going to learn about luminous objects, what are luminous and non-luminous objects, then rectilinear propagation of light. It means how light travels. This is what we are going to learn, and then further we will learn about applications of rectilinear propagation of light, and then about pinhole camera, its principle and its working, and then factors on which the size of image is produced and the factors on which it depends. And then we will also learn about shadows, its two parts, umbra and penumbra, and then natural shadows, which means eclipse. And eclipse are of two types, lunar eclipse and solar eclipse. So this is all which we are going to learn about. Now let us see what are luminous objects. Objects which gives their own light are called as luminous object. And here we can see the examples like sun, like fire, and like living things like fireflies and glowworm, to which we also say jugnu. I just hope you all must have seen it, right? Then second point is non-luminous objects. So those objects which do not give their own light are called as non-luminous objects, like moon. Moon actually does not give its own light. Then these trees, then I can say this book, then this pen, then this register. Okay, so everything which do not give their own light are called as non-luminous objects. Okay, then our second point will be, which we are going to cover, is rectilinear propagation of light. So what does it mean? The tendency of light to propagate along a straight line. So actually it means that light always travels in a straight line. Okay, and that is called as rectilinear propagation of light. And here we can see an activity. What they have done, they took 3 cardboards, okay, and they have made holes in all 3 cardboards at the same place, or I must say at the straight line, okay. And then at this end, when we will keep a lighted candle and hole is at the same line, so what will happen at this other end, when we will see through this hole, we can clearly see the light of this candle. Okay, so with this activity we can clearly see that light travels in a straight line. This is a straight line, okay, and in this straight line the light of this candle is traveling towards this side. Okay, so this is an activity through which they have showed us our like rectilinear propagation of light, or how light travels in a straight line. One more activity we will see from our book. So let us get back to our physics book now. Yes, first of all we will see the introduction part. Have you ever wondered how we see objects around us? Your obvious answer is with our eyes. Obviously, like if we will be asked that how we see things around us, obviously we all will say that we see things around us with our eyes. But actually our answer is not completely correct. It is not wholly correct, neither wholly wrong. It is not even completely wrong, and it is not even completely correct. Then what is the answer? Let us see. Let's see how. When you enter a room during the night without switching on the lights, are you able to see your bed or chair or table which are inside the room? The answer is no. But what happens when you switch on the lights? Now you are able to see the objects. Yes, now we can see the objects when light is switched on. This is because the light from the tube light falls on these objects. It happens only because when we switched on the light, so that light falls on these objects, and that is why the objects then reflect this light into our eyes, and as a result you are able to see it. So it means that tube light gives light of its own. As a result, you can see it. Such objects are called luminous objects. So it means luminous objects, even tube light and bulbs and lights are also called as luminous objects. Whereas the bed, the table and the chair do not give their own light but reflect the light incident on it, such objects are called as non-luminous object. So all the objects that do not emit their own light are called as non-luminous objects, and all the objects which give their own light are called as luminous objects. Now we'll see rectilinear propagation of light. First of all, let us see its definition. Rectilinear propagation of light is the tendency of light to propagate along a straight line. Let us understand this further. Again, they have showed us another activity. Okay, take a lit candle, view it through a pipe. First, when the pipe is straight, and second, when the pipe is bent, as shown in figure. What do we find? We find that when the pipe is straight, we can see the lit candle, but not when the pipe is bent. This shows that light travels along a straight line. So the activity says either pipe or either straw. I just hope you all know what is a straw. We can take a straw and then at one end let us see through it, okay, and at another end let us keep a candle, okay, and then when we will see through a straight straw we can easily see a candle. But once I will bend this straw from this middle part, what will happen? This light will also get bent, right? So along this place we cannot see this candle because that straight path is not there. Okay, so this is how they have showed one activity of how light travels in a straight line. Now let us see it again in a different case. Take three cardboards A, B and C, make small holes in their center and place them vertically as shown in figure. So this is what we have already seen in the beginning of the video, right? That we place three cardboards, from one end we will see through it and from another end we will place a candle. Okay, so we will see that we can clearly see the light of the candle through these holes. Okay, see A part, viewing through the holes in a cardboard to understand the rectilinear propagation of light. One more thing, like here also we can see, place a lighted candle in front of the cardboard A. When we look through the hole in cardboard C, we find that the candle flame is visible as long as the holes in the three cardboards are in a straight line. Displacing any one of the cardboard obscures the view of the candle flame. So it means if we will just change the location of the cardboard, what will happen? These holes will not stay in a straight line. As you can see, these two are in a straight line, but they have actually changed the place of this cardboard. So this hole is not in a straight line. So we cannot see the candle from this end. Okay. This shows that light travels in a straight line. The picture below shows that light travels along a straight line. It means they have showed the rays of the sun which are falling on the earth. So actually even the rays of the sun also falls in a straight line. Okay, now some of the applications of rectilinear propagation of light are the phases of moon. The phases of moon, I just hope you all must have seen it. Then solar and lunar eclipse. Solar and lunar eclipse. In Hindi, they are called as Surya Grahan and Chandra Grahan. And then shadows. And then pinhole camera. Then photography. So these are the examples of rectilinear propagation of light. Now let me explain how photography is an example of rectilinear propagation of light. Now see, if I am focusing this camera only on this picture, so is it covering this part also? Like at the time when I am focusing only on this part, will it cover that part also? The answer is no. So it means the lens that is there in my mobile is only covering the area that is falling in the straight line. So it means photography is also an example of the light travels along a straight line. Only the objects that are falling, or the frame that is there in a straight line, only that much frame this lens will cover, right? Then pinhole camera. Pinhole camera, we will learn about it in our next class. We will discuss this topic in our next class. So that time we will come to know that pinhole camera is also an example of rectilinear propagation of light. Shadows. I just hope you all must have seen shadows. Yes or no? See, these are shadows, right? This is how we can see our shadows, especially at night time. And in daytime, the light that covers or the shadows that are formed through light is sunlight. So, whenever light falls in a straight line and an object, or let us say I will just stand and cover that light, it will create a shadow. So this is how shadows are also an example of rectilinear propagation of light. Then phases of moon. One day it becomes like full moon day, and one day no moon day, and rest of the days, I just hope you all have seen there are different shapes of moon, right? So these are also the rectilinear propagation of light. Okay, and actually they also shows that light travels in a straight line. Similarly, these eclipse, solar and lunar eclipse, are also an example of rectilinear propagation. Okay, so that is all for today. So please read this topic, and meanwhile, and then in our next class we will see our pinhole camera. This is the picture of pinhole camera, but we will study its working and its construction in our next class. So that is all for today. Have a good day, students. Take care.